Hello everyone, it's August 24th. It's a little bit late today as I switched my work a little bit, kind of worked a little bit early in the morning, and then then I decided to do this. Look, we have a 10 response here, which means most likely it's a problem we have done before. But anyway, let's take a look. Complex number. Oh, Python has a complex number, so we can actually. Yeah, I think we can just do it using Python's complex number to do this. Real, imaginary, given two complex number, return a string of content representing multiplication. So anyway, I think we probably can. We need to parse it first, right? Because the pass in is a number. We can write it. I'm gonna write it, but the first solution is just gonna use Python's complex number to handle it, which will be very, very straightforward. And then we think about how to do it without using the library. Oh, the library is always fun. What do we have? We have this. So what we need to do is Python's using J, and I need to take this thing out, take that into an integer. So it'll be something plus something J. So what I can do is, let's say n1 is equal to def convert. So I'll convert a num from str into a is that int? Is that an int? I actually don't know. 1 plus 1 j, I think that's the one. Alright, what's type A? Complex. I can use complex. Can I use complex? I use complex, I guess. So what we do is the num list equals num dot, we're gonna split on the plus sign, and then we're gonna return num list 0. That's gonna be an int plus int num list 1, but we are going to eliminate the last one, and this one going to be j, right? So rest gonna equal to convert num1 times convert num2, right? And then we have to turn that back into a thing. So what are we going to do? How do we get the first part? A dot, imaginary. Okay. So we return str rest dot real, right? It's got real plus str rest dot imaginary, and then plus I. Yeah, I think this shall work. Well, I can run some test case on this. So first test case is 1 plus 1i, then 1 plus 1i. Result shall be 0 plus 2i. Second one, 1 plus minus 1i, then 1 plus minus 1i, and then 0 plus minus 2i. Let's see if they pass. They should pass. This is not difficult. Complex number multiplied. 1 and 2. Oh, how do we handle this? Okay, I actually don't know. Like, put more parentheses around? Huh. Well, we cannot do that. We'll probably have to do complex. Like say complex, real and imaginary. Okay, so that's not how we do it. This is how we do it. Complex. Do we need this? Nice. Good last name. Oh, wait, what? Answer is 0 plus 2i. Oh, that is not right. That is not correct at all. Oh, what's num1 and num2? 2 plus 0j. Huh? How? Should it be 1? Oh, I do the plus. That was my fault. Okay, so we're almost there. What we're gonna do is we're gonna call int complex numbers. Yeah, it's a complex numbers. Wait. Complex number has to be an integer. Right? It's an integer, so we just call int on this, and then we call int on this. There we go. Now we got it. So this is just using the built-in methods, so we don't have to consider anything. Then we can just submit. Should be right. Yep, should be right. So this is using Python's built-in complex number to handle. Very straightforward. No need to go runtime. 1 runtime. What do we get? 32 milliseconds. 50%. Yep, most people doing it this way. Alright, so now let's try to solve it ourselves. I mean, it's a math problem, right? It's a math problem. All we have is a plus bi times c plus di, and we can get a, b, c, d out. So we have ac plus bci plus adi minus bd, minus bd. So we just need to ac minus bd, and then bc plus ad. That's it. So that might actually be faster. Still need to convert though. Still need to convert. Still need to convert. Well, we can probably just do num list we can remove, okay, we can do this. We can do num1, right? We remove the last one we don't need, and this one we can do split on plus. That will give us 2 values, and then just say a, b equals this, right? And then c, d equals this. Then what we're going to do is we're going to return okay, so if I can also turn them into, we say int n for n in this, right? And then the same thing happened here. Let me say int n for n in this. Now we convert. Now we can do a times c minus b times d. That's the first one. So we're gonna do str plus this plus str plus I. It will be b times c plus a times d. Alright, give this a shot. Yeah, this probably is even faster because we don't have to, not using the built-in complex number. Because what I'm doing, this is very straightforward. Alright, let's try this one. Yep, this one's probably faster. It's the same. Alright, this is, I honestly think this is easier than what we had yesterday. Like, much easier. I guess it's 1,000 something. Oh, wow, 537. No, I don't think I've done this before. 537. People don't like it. That's fine. I don't have opinion about this. Split, oh, one. It is a stupid question. You don't need a rejects though. Why would you need rejects? Alright, what is this? We match this, or we match I. Now we split on this and split on I. Yeah. Alright, how short can it be? Like one line? Not really. Alright, anyway, so that's it. That's it. Nothing more, nothing fancy about this. Why all the comments? About what? 3 solutions. Oh, that was yesterday, I think. Well, because I commented it. I did have a comment. Oh, look at this. Yeah. Okay. That is interesting. Alright, so that's from yesterday. Left traversal, right traversal, yield from left. Wait, what the hell is this? What the hell is this? I don't like yield, because I never truly understand yield. So if I have a root, we're gonna just go left traversal. We go all the way left, right? We go all the way left, blah, 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 blah. And when we call next, it yields from, I'll just keep yielding, keep yielding, keep yielding. And then all the way it yields to the most left. So yield from is nothing. Then what? If yield from gets nothing, I think it just, yeah, it keeps going and then yield a root. Okay. So that, how we get the next will be the leftmost. That will be the rightmost. And then after that, when we call next again, we stop here, right? So we call next again. It remembers it's here. So we go here. Then we yield from the right. Left traversal. So we go to the right one, right? And then we yield from left again. All the way left, done. And do this, everything. And then if they're all done, what happened when one is done? Like on one root is all done. Now we go back to the previous one. Wow, this is very, very powerful. All right, I want to read this one more time, but this is some magician stuff. Yeah, this is magic level. Black magic shit. Yeah, this is really wow. This is like in order, right? Left, root, right. In order. This is in order reverse. And we've done it with yield. Hold on, how is this even possible? Um, well, it's possible because yield remembers your state, right? So you're saying we're doing traversal, in order traversal, using yield. Holy guacamole. Yeah, I mean, this is just, it's the same, right? If you want to do regular in-order traversal using recursion, we just, instead of yield, we just don't say yield, we just call this function, and then call this and call this, right? And what does yield give us? It gives us a stopping point, right? It gives a stopping point that allows us to traverse them one at a time. That's what the magic is, right? Actually, there's no magic. It's not magic. It's just regular function. There is a regular function. And all yield does is allow you to stop, right? It will allow you to stop, and it will let you go when you call next. So when you call next, it does one step, all right? And then calls next again, does another step. So if you don't call next, it won't keep going. It just stop right here. And because we are doing an iterator, so when we do the recursion and we have the iterator, so we can recurse iteratively, right? We don't have to do once, boom, run everything. We just stop. And I want the next one, we do the next level. On the next one, we do the next level. Oh man, this is good. Yeah, we call left. It will yield from this. So basically, we call this function, and then this function, then will yield from this function. Keep going, keep going, keep going until we go to the most left, which is nothing. Then we yield root dot val. That's the first yield, right? The first yield is root dot val, which is the leftmost node's value. Yeah, that is. Call the function, and the next still stands. So next said we want the next value, and then okay, we're going to yield from this, and then we're going to yield from this because we never get the value. We only get the value from here, and now we say we get the value from here. Wow, this is amazing. This is amazing. Generator object. Yeah, is it generator object or is it iterator? That's a good point. I don't know. When you call a function that has a yield, you get a generator object. But no code runs. And each time you'll extract an object from the generator, Python executes the function until it reaches a yield statement. Then pauses and delivers the object. When you extract another object, Python resumes just after that yield and continues until it reaches another yield. This means until the function runs off the end, at which point the generator is deemed exhausted. Yeah, I'll have to read this carefully, but this is a very interesting pattern. Anyway, I'll end it right here. I'm gonna do a little bit more study on how yield works. This is one of the magic in Python that's very important, I think. All right, see you guys tomorrow. Adios.